Hello everyone, Jason here with VC Edge. In this video we're going to be doing part 8 of the interface knife build, and this is going to be all about the blade core, or the actual cutting edge of the knife. It's a little more complicated than you might expect, but you'll see why. There's a lot of features that are designed into this that make the knife what it is. I'm going to be machining it out of some S35VN stainless steel, and the reason I'm using this is mostly just because it's a good proven steel. I've worked with it a bunch, and I know how to heat treat it. There's a lot of different really good steels that you can make blades out of. This is just one of the higher end steels that are available, and I will make knives with different steels at different points. It just depends on either what's available or what I feel like trying out. So for now it's going to be the S35. We'll do these knives out of that. I'm just going to be doing one at a time for this video, just to show how it's done and just to make sure that the processes are all working correctly. We're going to machine one side, then the other side, then up to a point, and then I'm going to do the heat treatment. Then we'll do some more machining, and then we'll put it into another fixture and machine it even more. So there's a lot of steps involved in this one. Should be really interesting. Let's get into it. Before we get started, I wanted to give you an idea of sort of what we're after here. And this is a good example because this is one of the test pieces that I did. This is a piece of natural G10, so you can kind of see through it. And you can see where the blade core extends into. And this is a slightly older design, but should give you a good idea of what we're trying to go for. As you can see, it's not just a piece of steel that's sandwiched into a piece of composite. It's more of an insert than anything else. But it's also not even just a flat piece. It has sort of an arrowhead shape to it, as you can see here. So you see that as a little step right there at the tip. I'll explain more about the reasons for that later, but this is what we're trying to machine right now. It's a very thin part. The central part of it is about 20 thousandths thick. We'll be machining one of those out of this piece. Let's throw this in the machine and get it going. Zeroing this on the top of the parallel and the back jaw of the vise, and then I'll measure X with the stock inside. So for the X-axis 0, I've got it set to a specific place that I'll remember for when I do the flipped operation. I've got this all set up in the vise. It's pretty simple, just a normal setup on parallels. Doesn't really matter how deep it is, as long as the tools will clear. It's not going to get into the edges or anything. I'm going to leave a frame around the outside. And I'm going to be machining some parts of this to size, and other parts are going to be left oversized for future operations. Got 5 different tools that are needed to do this. Got a 1/8 inch end mill, a spot drill, a 1/8 inch ball end mill, a 1/4 inch end mill, and a 1/8 inch carbide drill. These are all the same types of tools that you use on titanium, like the coatings and everything. They're all exactly the same, just some slightly different feeds and speeds. So one more thing is I've chosen to do this machining while it's in its softened state. It's a very thin part. I could heat treat it just as it is and then do the machining, but because it's being machined so thin, the tool pressures and things would possibly cause quite a bit of deflection without some really special holding fixtures. So machining most of it while it's in the softened state gets things a lot more accurate, and then I just have to do a little bit of machining after it's been hardened. Alright, so I've got this set up on the other side now. I'm going to zero it on the top of this because that's the surface that I chose as a reference. Last time it was the top of the parallel, now it's the top of the stock because it's been flipped over. So I'll zero that and then zero the X over here, which is the same spot that it was before. Y stays the same. In case you're wondering why I re-zero the Z-axis after flipping it over, it's because that way I don't have to worry about what the actual material thickness is. Even though this stock is ground nice and flat, its thickness can vary from one batch to another. So as long as I program it for like the maximum thickness that I expect to see, the parts will come out the same every time. Is machined out for the pre-heat treat operations, all done. Machined beautifully, although maybe a little slow. I could work on the feeds and speeds a little bit. The only parts that are actually to size are this this flat area here, these holes, and this little choil in the back. And you'll see what that's for later on. But yeah, looks really good. It's ready for heat treat. One thing that's interesting to note about these holes that I'm using here, I use the drill to drill these to size, partly because the 1/8 inch end mills aren't actually 1/8 of an inch. An 1/8 of an inch is 0.125. And 1/8 inch end mill, pretty much all the ones that I've ever seen are actually a 0.1235 diameter for whatever reason. Something about the way they grind them, but no matter what manufacturer or what type of end mill it is, it seems like they're always the same within half a thou or so. So the drills, though, for some reason, they are exactly 0.125, at least the ones I've been using. So if anybody knows why that is, let me know. But that does mean that in your CAM software, you need to program your 1/8 inch end mills to actually be 0.1235. Otherwise, you do run into some tolerance issues. Got these packaged up. They're going into the oven. This is going to be a cycle for S35, which is going to be 1600 degrees for 10 minutes, 2000 degrees for 15 minutes, and then tempering at 400 at 2 hours apiece, 2 times. I'm aiming for a hardness of anywhere from 58 to 60 Rockwell. Let's see what we get. While that's heat treating, I'm going to machine some special soft jaws to hold the part in some of the later operations. So we'll just cut to the machining footage of that. So here are the soft jaws, looking quite good. The finish on them is real nice. One of them I've got some features machined into, and one side is flat, otherwise they're the same. Got a couple of little built-in parallels on the top. I'll show you how these work as soon as I get them installed into the vise and get the parts out of the heat treat. There's our quenched pieces. I've actually got 2 of them in here. I kind of hope they didn't stick together. It shouldn't be a problem. I'm not really squishing them down hard enough to forge weld them, but you never know. All right, so the heat treatment is done. It didn't turn out exactly quite like I thought. They didn't stick together like I was worried about. Got a completely different problem instead. The hardness is actually just right. It measured out at 59 Rockwell. That's just what I wanted, but because I put two of them stacked side by side, this one and the other one both came out the same. They have this pretty severe warp. They're like potato chipped. And the cause for that, I should have thought about this, but the pack, after getting really hot and then you cool it down really fast, it creates a vacuum inside, and so the two sides of it suck down. Because I had these stacked, which I never should have done, I've never tried that before. Because I had them stacked, it sucked in the two sides and just potato chipped both of them in the opposite directions. So that was kind of dumb, but won't be doing that again. I'll just do another one of these. I don't think I can save this one. I'll just do another one in a single pack, and we'll try that. At least we know the hardness is right, so that recipe works. All right, this one's good to go. Looks nice and straight, and measures 59 Rockwell. That's exactly right. Most knife makers take their knives and machine, if they're machining the bevels and not grinding them, they put their knives down flat and then machine the bevels with some kind of ball end mill or something in this direction. That uses the very tip of the tool, and you know, it's not the best situation. I have a somewhat unique opportunity with this because the bevel on the steel is so short. I can actually take this and hold it vertically using these holes here for locators. I just have to, now that it's hardened, cut around the outside of this to get rid of the frame, and then I can put it into the soft jaw and hold it straight up. And that way I can use the side of the end mill to cut these bevels, and it should hold it nice and securely because it can go all the way up almost to the edge. Put it into the vise and cut out the major portion. That's part of the reason I put this little notch here, so the end mill can plunge into this area and not have to go through hardened steel, but it can use the side of the end mill to get in and cut these slots out. There's a thin section left. It's not very much, like 15 thou. So yeah, let's go inside the mill. Alright, so if I've set this up right, I can use some of the features that I've machined into this to locate the part and zero everything. Drop into this slot and then machine out this front edge, and then I'm going to come in and machine the back, not all the way. Same thing back here. That'll leave a little tab on the back. This will be loose. I should be able to just break it out. One more thing, since this is hardened steel, you don't use coolant. Cold water will tend to fracture the cutting edges of the carbide when you're cutting something that's hardened like this. So I'll need to set up some kind of air blast. I do have a mist coolant system that I used before that I could probably stick on here just temporarily, and I'll just have to activate it manually for now. I don't have the relays and things to have that part of the control. Alright, so check out my air blast setup here. I think this might actually count as a machine mod. I have a fog buster that I've had for a while that I've got set up on one of these, like an indicator arm. Just a cheap one, you know, one of those eBay versions or whatever. It's all metal though, so that's good. And I just drilled and tapped into this coolant manifold clamp, and just deep enough to get the threads in. It's fairly short. Ended up, I think it was a 5mm 0.75 thread. So that was pretty easy to do. I went ahead and had some fun with some safety wire just to make sure that it didn't come loose. That thread is pretty shallow, so I wanted to make sure it didn't back off. A little bit of aerospace work there. Wraps around the manifold right here in the middle, and then comes up twisted and then hooks into this little hole that I drilled into the hex. So that should work. Just some 20,000 stainless steel wire. I ran the air line only. I don't have the coolant hooked up because right now I don't need it, but eventually I probably will. But just a silicone air line that goes all the way, follows the the coolant line all the way up and then up to the track into the back of the machine. I've got the fog buster canister just chilling on the ground here right now until I find a good place to mount it. Need to make it where it's somewhat accessible for refilling and whatnot. That controls the air pressure, and I've got the switch just mounted right here next to the enclosure, just in one of the existing screws, and I can just turn that on. And for now it's just air, so it gives a nice cone of air that's about that wide. I can sort of feel it right here. So it should work just about right. But I can of course aim it however I want. Also, I wanted to show you this. I was able to get this to fit by, can you see that? There we go. I was able to get this to fit on the original mount for the fog buster by disassembling the original adjuster mechanism. It's just pinned in, so you can unpin it and then slightly grinding the edges off of that, and it fits right through. So that made it nice and easy. I'll eventually have this set up as a relay so that the controller can handle it, but for now that's all I got. So, all right, let's go ahead and cut some of this hardened stainless. Here we go. To be perfectly honest, I'm pretty nervous about this. I hope it goes right. Alright, so the cutouts worked perfect. The idea is that I could just sort of, snap that off. That worked just about perfect. A little tough, but I could probably cut this a little bit further if I want to. Next time, it'll be a little easier. But now I just can sand that off on the belt sander, and it'll be ready for the next operation. Alright, just got this sanded, just took off that little excess tab on the back. I want to hold it vertically into these vice jaws, so I've got these little holes in it, and they line up with the pins that I machined into that, like so. They're just a little bit shorter than the piece is thick, and I can come in with the other jaw. Now it's clamped in and it's supported all the way up to the area that I need to cut. Before I cut this though, I do need to relieve the fixture. It's going to come in with a ball mill and it's going to go down a little deeper than what this is. So I'll put a shim in here that's the same thickness and machine that out with coolant on before I do the air blast machining on the hardened steel, because I don't want the end mill to be cutting aluminum without any coolant. It could get chip loaded into the end mill and get stuck into the flutes. So I'll do that first and then we can run this. There we go. It's a little trick for holding things in place where you're not going to be able to access them. Just a little bit of grease. That'll stay. Alright, so that thing's all clearanced out. Blade is in, it's ready to be cut. Feels nice and secure, so I think it's ready. looks pretty good. A little bit of weirdness here at the tip from some of the lead-ins. I'll have to fix that. But the main thing is that it is nice and even at the tip. So now that the bevels have been mostly shaped, it's still not quite sharp. I'm gonna put it into a little fixture and sand the rest of this on the belt. Here's my little fixture. It's just a squared up piece of aluminum that I drilled and tapped some holes into, and I've got a little plate. This is a piece of titanium and a shim on the back so that when I screw these screws down, it clamps in the blade. And then all I have to do is set this table to the right angle, and I can sit here and grind the bevels to a better finish. That'll make it a lot easier for some of the hand finishing later on after this is all bonded in. And I'll use a little bit of black Sharpie so I can see where I'm working. So that side's good. I do have to be very careful to not overheat this, otherwise it'll ruin the temper. But I should probably get some kind of a mist coolant to spray onto this. I'll have to get a little thing for that. But flip it around, do the other side. Alright, got it. I've got it basically to a 0 edge, so it even kicked up a burr on some places, so that's just perfect. It'll make it nice and easy to finish off. So there is the part, ready to go. I'm really happy with how things turned out. It's a lot of steps to go through, but a lot of them they're pretty short and easy to do, so that's just fine. It's looking good. Oh, I wanted to tell you about this little step that I put in here. The reason that I have that, you could just leave this as a core and you know, bond the composite to the outside of it. But what you end up getting is on the composite, you end up getting a knife edge. And that can lead to, it could start to lift the composite, especially if it's that thin. It's got almost no structure to it, or it's just resin at the edge, and that's no good. So leaving that little step there ensures that I have at least 1 or 2 layers as a structure rather than just a 0 edge. Having that thickness of carbon there will keep it from peeling up. Should hold together nicely. Looking perfect. It's perfectly centered. Yeah, that's excellent. Excellent centering. Alright, so there we have it. The blade core is all done and it's looking exceptional, if I do say so myself. This is arguably the most important part of the knife. It's basically what makes it a knife, having a nice hard cutting edge. I was really worried about how this would work out, making sure everything was going to end up with a good part, and it looks like it's working just right. So I'm pretty happy, and that means that we can move on to the next thing. Next up will be the carbon fiber blade body that this will bond into. So that part's exciting. We're getting really close to finishing this knife. If you're enjoying these videos, consider subscribing to the channel so you don't miss anything. And with that, I'll see you on the next video.